The very first logic gate we looked at was the buffer gate. This is used when a boost in signal strength is needed or degraded signal needs amplifying. It is also a good place to start as it is the simplest gate to understand. Let's recap with what we know about this gate. It has one single input and one single output. We have seen how this works in theory. We now need to explore it in practice. Here's our theoretical schematic diagram, our breadboard and power supply, also our truth table and of course the logic gate symbol. The first item that we should be using is a push switch. It does not really matter where on the breadboard it is placed as long as we follow the schematic diagram and how it is connected to the other components. We can see that the switch covers a total of 9 connectors, 3 by 3 connectors. When it is in the off position, there is no connection between these two rows, but when it is operated, there is a connection between them. Next, we need an LED safety limiting resistor. This reduces the voltage and current that is supplied to the LED. Connecting the LED directly to a power supply can cause damage to it. A common material used in the manufacture of resistors is carbon. The higher the level of carbon, the more resistance to the flow of electricity. The resistance is measured in ohms, kilo ohms and even mega ohms. The value of these resistors can be identified with a colour chart as shown here. If we look back at our schematic diagram, we can see the resistor is connected to one side of the switch, so a suitable place would be on this side of the switch. The other side of the resistor is connected to our LED, and these come in all different colours, shapes and sizes. Some components are polarity dependent, just like this LED. If we connect this the wrong way around, there's a good chance it will burn out. Normally, the longest leg is the positive. We now need to connect the power supply links to our circuit. We can see that the positive is connected to the switch, so we place a link from the positive to the left side of the switch. We can also see the negative of the LED is connected to the negative of the power supply. Finally, we connect the power supply. First, let's just check out our schematic diagram. The flow of electricity runs from the power supply to the switch, and since the switch is open, the LED fails to light. When the power reaches the breadboard, the whole top row marked as positive will become positive. We have a link that is connected to the left-hand side of the switch. Again, this row will become positive. But once again, the switch is off, so no current can flow and the LED remains off. We could say that when the input is 0, the output is also 0. Let's reset the circuit and close the switch. This time the current can reach the resistor, then the LED completing the circuit and the LED lights. With our practical circuit, we close the switch. The current then travels along the top row and also through the link and the left-hand side of the switch. Since the switch is now closed, current can flow across the switch, through the resistor, into the LED, and finally back to the negative of the battery, allowing the LED to light. We could say that when the input is 1, the output is 1.